Hi, Miss Marion here. We are doing Unit 8, Lesson 14 and 15 today. But first of all, we're going to go ahead and work on our starter. So go grab a piece of paper, write these down, answer them, and then come back to me. All right, so let's go ahead and go through these. So number one, let's check it. So are my variables the same on both sides? Yes. Are my numbers the same on both sides? No. So on the left-hand side, technically I have 2x plus 0 equaling the 2x minus 1. So both sides, so the variables are the same, but the numbers are different. So this is no solution. All right, let's go ahead and find our slope. I like to go ahead and stack my points. For me, it makes it a little bit easier to understand it. So how much do we go from a 2 to a 3? We're adding 1. 5 to a 6, we're also adding 1. Remember, it's vertical over horizontal, so it's 1 over 1, or just 1 as our slope. All right, find the square of 3. So it's kind of a little weird as far as saying it. So really what we're looking at is 3 squared, which is 9. On number 4, we're looking at the square root of 16. So square root of 16 is 4. Now remember, it also can be negative 4. So 4 and negative 4 is the square root of 16. All right, number 5. Let's go ahead and answer that. What I like to do is combine like terms on both sides. So 5x minus 2x is 3x. Still have plus 2 equals, and then we have 3x minus 4x, which is negative 1x, still the minus 6. I like to put all my variables on the left-hand side, so I'm going to add 1x to both sides. So I have 4x plus 2 equals negative 6. The 2 wants to be on the other side with the negative 6, so we're going to subtract off 2 from both sides. So we're going to get 4x equals negative 8. Let's go ahead and divide by 4, because 4 and x are multiplying. We are going to divide, so then x is going to equal negative 2. Again, these are the type of stuff you're going to see on the RISE test and also end of level test. That's why we're doing our starters at this time. All right, grab your workbook, turn back to page 139. Let's look at lesson 14 and 15. So 14, I understand that every number has a decimal expansion. I can write a fraction as a repeating decimal. And then 11 is I can write a repeating decimal as a fraction. I understand that every number has a decimal expansion. So pretty much we're kind of doing the same stuff. Give yourself a give yourself a sentence first on both of these. Also a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And 4, I can teach it to my friend. All right, to kind of help us understand what decimals and fractions, those kind of things, turn to page 115, write down one thing that you notice, and then one thing that you wonder, and then come back to me. All right, something you can notice, the highlighted areas can be written as fractions. There's parts and whole. It's blue. There's different boxes. Some of the boxes are shaded, some of them are not. All of them are equal, broken into equal parts. A couple of things that we can wonder. Why do we have these? Why is it blue? Why is it broken into different several parts? Why is only part of it colored? All that kind of stuff. So we're actually going to kind of use this as far as decimals and fractions for today. All right, let's turn to page 116. On page 116, we have this number line, and we're going to do 1, 2, 3, and 4. We're actually going to do them all together because it kind of makes sense. It says, mark the midpoint between 0 and 1. What is its decimal representation? Mark the midpoint between 0 and the new point. What is that one? Repeat step 2. How did you feel the value of this number? And then what are we actually doing with this information? So go ahead and do the midpoint again, do the midpoint again, and let's figure out what these are. So pause, do that, and then come back to me. All right, so we want to find the midpoint. So we're actually going to do number 1. So we're going to mark the midpoint. And that as a decimal point is 0.5. right? Because if I take 1 divided by 2, it's 0.5. Now I want to go ahead and do it again. So we're going to go ahead and mark the midpoint. So I'm going to take 0.5, I'm going to divide it by 2, which is 0.25. And then let's go ahead and do it one more time. We're going to find another midpoint between 0 and 0.25. So we're going to take that 0.25 or 0.25, divide it by 2, and we're going to get 0.125. Okay, so we're going to kind of look at decimals today, kind of how it is. We're also going to be talking about fractions. So we kind of took this 1 and we broke down into fraction, and even smaller fraction, and even smaller fraction itself. All right, so just kind of going along with what we just barely did, notice how I have, this is kind of the fraction, like the skinny and fat fraction kind of stuff. So notice I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that makes a 1, right? So if we look at it, this is 2, so it's 2 of the 10, which would also be reduced down to 1 over 5. But notice how 1 over 5 and 2 over 10 have the same decimal, okay? So this is our fat fraction, needs to reduce down to 1 over 10, 1 over 5 to make it the skinny fraction, but all the decimals for both of these are exactly the same. And this is kind of the reason why with this number line. So let's kind of remind us how to go ahead and write fractions with decimals itself. So if we are looking at it, we want to go ahead and write 0.25 as a fraction. Easiest way to do it is to notice where the end decimal is and what position that is. So the first position is the tenths. Second position is the hundredths. So we're going to take the 25 and we're going to divide it by 100. That's how we start it. Now we have to ask, is this a skinny or a fat fraction? Okay, so this is a fat fraction. Let's put it in our calculator. Tell it to simplify. And it's going to simplify down to 1 over 4. Okay, so let's go ahead and try this one here. So what is this ending point? That's the thousandths. Okay, so we're going to have the whole number. So the 1258 over 1,000. And then we want to take it and we want to see if it's skinny or fat. So what can we go ahead and simplify that into? Okay, we want to take it, we want to simplify it. I know that I can divide the top and bottom by 2. So what is 1,000 divided by 2? That's 500. What is 1,258 divided by 2? That's 629. So this is the simplified of the 1,258 divided by 1,000. Simplify it down to 629 over 500. All right, let's turn to page 116. So rational numbers. Rational numbers are fractions. They're decimals that stop and then decimals that repeat. Okay, so we're going to kind of look at these and we're going to go through A through F. And we're going to take all of those and actually put them into fraction form. So go ahead and pause. Go ahead and put those into fractions and then come back to me. All right, so let's go ahead and walk through these. So A. The 2 is in the tenths position. So this answer is going to be 2 over 10. And then let's go ahead and simplify it down to 1 over 5. B. First of all, we have to take the square root of 2. So square root of 4. Square root of 4 is 2, and then give it a negative. And then how do we take a whole number and make it a fraction? We're going to do it over 1. All right, C. This is the thousandths position, so it's going to be 333, so 333 over 1,000. And you can actually check these and make sure. If you do 333 divided by 1,000, you should get 0.333 as your answer. All right, cubed root. We did this yesterday, so remember we need to go 3 and then second caret top. So it kind of looks like this. And we're going to put in 1,000. And that answer should be 10. So what number multiplied by itself 3 times makes 1,000? That's 10. And again, how do we make a whole number? A fraction, we're going to put it over 1. All right, let's look at this. So there's 1, 2, 3, 4, 5, 6. So that is our bottom part. So it's 1 with a 6 zeros, 1, 2, 3, 4, 5, 6. And then you take whatever the number it was before, so -1, and the 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 with a 1. Strange fraction, but that's what it is. All right. Square root of 1 over 9. So put it in your calculator. What do we get? It'll be 1 over 3. All right, all rational numbers have a decimal representation. So let's go ahead and take all of these and let's put it into what it is decimal wise. So go ahead and pause, answer that question, and then come back to me. All right, so 3 divided by 8. 3 divided by 8 is 0.375. All right, 7 divided by 5, what is that? Oh, it should be 1.4. 999 divided by 1,000 is 0.999. All right, keep on going. 111 divided by 2 is 55.5. And then a cubed root, so 3 second caret top, and then put it in as a fraction 1/8, and that should be 0.5 as our decimal. So again, a rational number is a fraction, a decimal that stops, and a decimal that repeats. Right? So remember, and then irrational is a decimal that keeps on going on forever and never stops and never repeats, and it goes on forever and ever and ever. All right, so let's, in lesson 15, our goal for lesson 15 is to go ahead and take repeating decimals, and we're going to go ahead and put them into fractions. So underneath this module, I actually have a note page. You probably want to go ahead and either get out a piece of paper and write it down, or print off the note page because it's going to help you. These are the steps to go ahead and to take a repeating decimal and put it into a fraction form. So number 1, we're going to call the repeating decimal x. 2, we're going to create an equation that gets a decimal point behind the repeat. 3, we're going to create an equation that gets decimal point in front of the repeat. We're going to subtract behind minus in front. We're going to get the x alone, and then we're going to go ahead and simplify the fraction. So go ahead and make sure that you have written down all these steps, because we're actually going to go through it on example 1 and 2, and then you're going to do some yourself. All right, example number 1. Example number 1, we're going to take the decimal, the repeating decimal, and we're going to call it x, meaning we're going to say x equals 0.186, and the 86 is what is being repeated. Step number 2, we're going to create an equation that gets the decimal behind the repeat. So if we look at it, behind the repeat is going to be over here. How many times did we move that decimal? It's going to be 1, 2, 3. So if we remove the decimal, we also have to kind of move both sides of the equation. So we have pretty much 1x, and we're going to move it 3 times. 1, 2, 3, put in our zeros. So really the new equation where the decimal is behind the repeat is going to be 1,000 x equals 186 point, and then what is repeating? It's 8686, and it kind of repeats forever. So this is the behind equation where the decimal is behind the repeat. Now we're going to go ahead and make an equation where it's in front. Where is it going to be in front? That would be here. How many times do we move that decimal place? That's going to be once. So we're going to have 10x on one side. Let's line up our decimal points. If I move that once, I'm going to have 1 point and then 8686, not 88. Hold on. So we're going to have it as 8686 and then repeating. This is the equation that's in front. Then we're going to take these and we're going to subtract the behind minus the in front. So notice how it's the behind minus the in front. Let's grab our calculators. Let's do 1,000 divided by 10. 1,000 minus 10, and that's 990x. Notice how the 86 over here at the end, all of these are 8686. If we subtracted those off, that would make it 0, right? So really, we have 186 minus 1, which is 185. Now we want to go ahead and we want to get x by himself. How do we get x by himself? 990 are multiplying. We're going to divide by 990 on both sides of the equation. We're going to get x equals 185 divided by 990. Last thing we need to go ahead and check is if it needs to be simplified. Put it in your calculator, tell it to simplify. And it does. What is it simplified down to? Well, that's going to go ahead and simplify down to 37 over 198. So then this is the fraction form of the 0.186 and then 86 being repeated. You can actually divide that out. If we do 37 divided by 198, you'll actually get that same decimal repeating all the way until the end of the view of the calculator. All right, so let's go ahead and let's try this again. So what is step 1? We're going to call the repeated decimal x. So we're going to say x equals 0.7, and then 88 is being repeated. Next, we're going to make an equation where the decimal is behind the repeat. So 1, 2, 3, again, we moved it 3 times. 1, 2, 3, x, and then it's going to be 788, and then 8s are being repeated. This is the behind. Step 3, we're going to go ahead and create an equation where the decimal is in front of the repeated. So we moved it once, so it's going to be 10, and then 7.88 being repeated. This is where it's in front. Third, we're going to go ahead and subtract behind minus the in front. 1,000 minus 10 is 990x. And then 8 subtract off, we're going to have 788 minus 7. That's going to be 781. Then we want to go ahead and we want to get x by himself. So we're going to divide by 990 on both sides. So we're going to have x equals 781 over 990. Let's put it in our calculator and see if it reduces down. It does. What does it reduce down to? 71 over 90. So then 71 over 90 will give this repeated decimal information. Go ahead and try that. You can do 71 divided by 90. It's going to be 0.78, and then the 8 is being repeated. All right, so you're going to go ahead and take some time. These are different examples of taking the fraction and then putting it into, taking the repeating decimal, put it into a fraction. We're going to leave as an improper fraction. So if it's bigger on the topper, leave it improper, okay? So I don't want mixed fractions. Go ahead and pause, work through these, and then we'll actually go through it as far as answering every question. All right, here is number 1. Number 1, the answer should be 11 over 90. Notice how we went ahead and made the decimal point behind. We moved it twice, so it's going to be 100x. It's a little bit different than what we did in our notes. And then it will be 12.2. Going in front is going here, so we moved it over once. That is 10. X equals 1.2. These are repeating, but we know we're going to go ahead and subtract them off. You get 90x equals 11 divided by 90. It's 11 over 90. It is already in simplest form, so we're not going to simplify it any further. Here is number 2. So x equals 1.5 repeated. The behind is we moved it over, so it's behind here. So we moved it once, so it's going to be 10x equals 15.5. And then in front, it's already in front of the repeated, so we didn't need to change this equation. Go ahead and subtract it off. We get 9x equals 14 divided by 4. This is also in simplest form. Notice how it's not a mixed fraction, it's actually improper. Here's number 3. So we moved it twice, so it's going to be 183.3. So 100x equals 83.3. In front is we moved it twice, so it's going to be 10x, 8.3. Subtract it off, we get 90 and 75 divided by 90. 75 over 90 does simplify. It simplifies down to 5 over 6. So 5 over 6 will actually give this repeating decimal back. All right, number 4, a little bit different, okay? So x equals 2.75 repeated. Behind is going to be over here. We are moving it twice, so it's going to be 100x equals 275.5. In front is going to be between the 7 and the 5, so we moved it once, so it's 10x equals 27.5. Subtract them off, we get 90x, 248, divided by 90. And again, notice how I'm like, oh yeah, I can divide the top and bottom by 2, simplifying it down to 124 over 45. So hopefully you understood all of these. If you need to go ahead and rewind and go back through them, please do, because this is one of the things we have to know for 8th grade core. All right, so remember the methods of going ahead and taking a repeating decimal and putting it into fraction form, making the 2 equations, and then go ahead and subtract them, and then find out what that fraction will be. Go ahead and go back to page 139. So I can understand that every number has a decimal expansion. I can write a fraction as a repeating decimal. That is for lesson 14. And then lesson 15, I can write a repeating decimal as a fraction, and I can understand that every number has a decimal expansion. Go ahead and write yourself a sentence for both of these, because we did lesson 14 and 15. Give yourself a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. We are just doing 1 practice problems, but it is a mixture of 14 and 15 together. So make sure you go ahead and go through those practice problems. I hope you have a good day. If you have any questions, please email me. Have a good day. Bye.